At AI-ALOE, we are using large language models to build educational tools.
What is a language model?
A language model is a system that assigns probabilities to words given a history of words.
The best language models are transformers, a type of neural network architecture. Some limitations of transformers are that they can be biased, they're difficult to interpret, and they're expensive to pre-train.
We can overcome some of these limitations by fine-tuning our own custom models. We fine-tune in 3 steps. The first step is to collect labeled training data in the target domain. The next step is training the model on a specialized computer. Finally, we evaluate the model on a held-out portion of our dataset. Our first 2 models are part of a project called ITEL, a framework for intelligent textbooks for enhanced lifelong learning. In ITEL, students write summaries at the end of each section to show what they've learned. Then, our AI models score the summaries and provide feedback. Our first fine-tuned model is a summary scoring system. Our training data was a dataset of 4,000 summaries that were scored for content and wording.
This is an example of a document classification task. We tokenize the text and output a score. We trained this model from Longformer, a pre-trained transformer-based large language model that uses sparse attention to handle longer sequences. After fine-tuning, our model explained 79% of the variance in content scores and 66% of the variance in wording scores.
This allows us to provide learners with meaningful feedback in ITEL. Our next model was built to extract key phrases from textbook sections to provide learners with feedback. Our training data for this model comes from OpenStax, an online collection of digital textbooks that are annotated for key phrases. The training data consists of 50 textbooks with over 27,000 key phrases. This is a token classification task where we assign a label to every token that indicates whether it's part of a key phrase.
This model was also trained from Longformer, this time using a natural language processing library called Spacy.
Our key phrase extraction model recalled 79% of key phrases with a precision of 65%. When a learner includes a key phrase in their summary, ITEL will provide positive feedback. When a learner gets stuck, ITEL will suggest a key phrase for the learner to discuss. Our final model is part of a project to develop an automatic system for de-identifying student writing.
We call it Pillow. Pillow works by labeling, identifying information, and then obfuscating it.
Student names are the most common form of identifying information in student writing and one of the most difficult to annotate. To tackle this problem, we collected 6,000 essays from a massively open online course and annotated them for student names. This model was also trained from Longformer using Spacy. Our model recalled 84% of student names on the held-out testing set with a precision of 68%, which is a significant improvement over other de-identification systems that were not trained on educational data. A demo of Pillow is available on Hugging Face Spaces. You can type in a text and see how it would be anonymized using a hiding in plain sight obfuscation strategy. All our work is open source.
Our research code is available on GitHub.
And our models are available on Hugging Face.